So today we are going to focus on web server, web applications specifically. The majority of the businesses, as you know, use web server and web application. Um, so now whether they don't have a web application, they typically would have a website about the company or something like that, right? And that's probably one of the most common area that is being hit or discovered for attacks, right? What you see is you would see the services that is needed. I know some of you have seen, right, web services before and what you would use with that. Let me double check something real quick. I want to verify something real quick. Okay, we're only doing Cali today, so if I don't have to get you your drives. Okay, so if we're looking at web server attacks, the motives for the web server attacks are similar to what you've seen in many different type of attacks, right? But typically, an attacker would try to get access to your systems for the back end. That means that they want to be able to get into like an admin account, either through traversing or to be able to find the weakness in your web server. Now, if your web server contain important sensitive data, let's say that I have a web server that hosts application for my patients to be able to make appointments or fulfill their prescription and so on, that might contain healthcare data. So to be able to obtain information or even credit card information for some e-commerce website, or typically they would try to also cause disruption, right? So these are the main common motives that you would see. Now, how can they get into the system, right? So you know that there would be credential that would be required. So typically they're going to try to brute force accounts, logins, right? So trying different combination, and now the tools for brute force can be varied. The way that we can control brute forcing is we would do a lockout, right? If you ever log into your bank account and if you forgot your password, right, after so many attempts, there's a delay. So it might lock your account until you contact the tech support, or you have to wait 30 minutes or an hour, etc., or even a day, right? It depends on the policy that is set to control brute force. So they would use a tool to automate the credential. And the way that they would do this is they would launch the tool and it's going to enumerate, it's going to plug in variation of account information. They can also do credential dumping, which is a way that it uses memory to be able to acquire what's stored in the memory to plug that in. As you know, that some account, right, would be stored to the system because it's able to pass the security token or information so that way the account can be authenticated. And then the third area is credential stuffing. This is a way that you would log into different accounts using same username and password, which a lot of people do, right? To make it easier to remember your password or avoid password fatigue, right? People would typically use similar or the same account information. And then there's dictionary attack where it would plug in dictionary words. So we already know the practice for password, right? Stay away from common words in different languages. Also use variations in your characters so that way that it's harder or it takes longer to enumerate, and then to be able to have longer passwords. And as you know, password is stored with hash algorithm. So a lot of the common password brute forcing, as you know, it referred to the hash. So in Windows environment, you would typically see hash for NTLM. MD5 hash is very vulnerable. So even if you use like higher algorithm like SHA 256, it's all about time and resources, right? So if they're able to capture the hash, they're able to match the hash with the encrypted password or the shadow password, and that's how they can generate the session. And then next week, we're going to spend a little bit more time on SQL injection to kind of see, because your accounts is typically put into a database, and in that database would have your username and your password. So they would go into that database to be able to find your account information. So what are some of the motives behind web server attack? The motives, we know the first three area we talked about: to gain unauthorized access, right? To be able to obtain sensitive data. You heard about the recent breach, right? They said that like as soon as the breach happened, the data surfaced on the dark web, and they were trying to sell the data for quite a bit of money. So in some corporate environment, sensitive data or data in general is pricey, right? The cost of their data, the cost of that access, the price of that access is high. So on average, you would see that on the dark web, if you look at people's social security, a piece of data like that contains sensitive information, it can go from like $1.33 to a few dollars, right? It really depends on how valuable or how effective that sensitive information can be reused. And then causing server disruption, which is what we typically see with denial of service attack, right? To maximize, right, to capitalize on the resources that's available on that system to take it down, right? To really use all the requests. So we talked about DOS quite a bit a while back. So the type of attacks that you would see with web servers is that they would use brute forcing to get access. They can also use dictionary attack, like we said, credential dumping, stuffing, or SQL injection. And SQL injection typically start with SQL query to the field that you would see, like login field, username and password, right? Or in some sense, they also can extend that to code or script that can be injected into an area that the user would typically enter or input their information. And in the database, if you're looking at relational database using SQL, a lot of the times the server would respond based on the query that's generated or the script that's submitted. So some script can be more advanced or the query can be very simple. We'll see some of that next week. So if they're able to obtain some information in the response from the server, then they'll be able to use that information to escalate that attack in the next level. And for web server, we would also see cross-site scripting. Cross-site scripting is a way that they can obtain information, right, through the scripts that's being used. And a lot of the services that we looked at, typically your web server runs HTTPS with TLS, right, and the version of TLS. So the protocols that's used is used for a certain service. And as we know, protocols are vulnerable. Also, web development in the design sometimes has flaws, right? Traditionally, when I assess web and web applications before, some admin, they would actually have a folder on there for their back-end account because maybe multiple people are accessing that to be able to share share the work to configure, right? They might have a developer and they might have an admin, and so when you traverse through and you can look at some repository that actually contains credential or sensitive information that way too. Once they get in, the attacker would then also try to manipulate the content. So a lot of the code are typically what, HTML, JavaScript. Sometimes if you have like web application, it might be running Python or Java, etc., right? So you can go through, you can modify the code, ask the attacker to see. Now, when you assess this as a pen tester, you're going to do the same thing. You want to see if your web servers are accepting brute force input, right? If it's accepting enumeration. Now you can control some of this with web application firewall. You can also create, right, or build your website to have some security measures. So we have to think about like DevSecOps in the sense where if we're running web applications and websites with our web server. Now, if they manipulate the content, typically you might have a link where you can say submit some kind of form or input. It can redirect the user to malicious websites. So cross-site scripting typically has this component. I'm going to give you an example. Let's say that I'm an attacker and I'm performing cross-site scripting on an e-commerce website. And I'm using a typical user account. I want to be able to, let's say, like steal their purchases, right? So what happens is I'm gonna run my code and it's going to take over the session for that user. And then and I also need to do a man in the middle with that typically. And then on the other end, I would redirect the user back to the home page of that website and make them log in again, right? I can also capture their password when they do that. So in that sense, they're going to have to write additional code in order to keylog that password with the redirection and be able to obtain the credential or their security token for that session, right? Using the session ID, and we talked in the extension about that. And so most user would be like, oh, something went wrong. I'm just back to the home now. I'm just gonna go ahead and relog back in. What from an attacker standpoint, they want the least suspicion as possible. So in that approach, what you would see is you would want to think about that when you're pen testing, right? To see if your user accounts are vulnerable. And you can ask them to give you a test account to be able to do that, or you can look at ways to obtain the account and be able to do that in blind testing. So that means that it can be unresponsive to that step in the process, right? So if the user is submitting a transaction, let's say I'm completing my purchase and I click submit, if I'm redirected back to the home page, I just say, oh, maybe something is wrong with this website. I'm just going to relog back in and go and look at my shopping cart again, right? But little that they know that that session has been hijacked and through cross-site scripting and man in the middle, and then I'm now back to square one, right? Or sometime I just get a 404 error and I say, oh, maybe the website is down. I'll just go ahead and click refresh, right? And or open my browser again and try to relog back in. So typically from a user standpoint, they might not be responsive to what's happening on the back end, right? So in that period of time, that session is now being hijacked by the attacker, and they are now, right, accessing that account and be able to, I don't know, modify it, changing the shipping address and so on. So some of it comes back to how you configure your server, right? How you protect your user accounts and your resources or your information that's stored. Okay. So you typically see cross-site scripting being used with other form of attacks to be successful in the objective that's what you see here. Any question? Okay. So this information, you can go down to the cross-site scripting. So XSS stands for cross-site scripting attack. And I give you the breakdown in different technique, right? If So if you want to get into this area, I would encourage you to learn web development, right? We run HTML classes. They're like short and sweet. So you can do both like the HTML and CSS in one semester. But it goes over like the design aspect of web and then be able to code it. Now you said, well, there's AI, and why would I want to be a web developer? But AI can only generate so much based on what the data that it has, right? But you still have to think about like web development with the design aspect. So in here, it talks about DOM-based cross-site scripting. And this is where the attack really focus on payload execution by modifying what's called document object model. So in web development, we use this to really build out, right, the environment that will be allowable for the browser to load the web content. So that means that on the client side, if this happens, it's going to execute the code that is injected, right, for the payload. So why do I say payload? Because when you do a get, you actually getting data from the web server to see the home page or whatever page that you're trying to visit. So what that means is at this time, right, it's going to execute the attack here where the client code that is typically from the web server doesn't run. It runs the change code where it would go into an unexpected manner on the browser. So this is considered a DOM-based cross-site scripting. And also you would see that a lot of the times web developer use JavaScript for the user to interface. Things like username and password to log in, and that button you click submit, that is typically being created or written in JavaScript. And then linking with URL, that's in HTML, right? So with this, it talks about how it passes the sync with support for dynamic code execution. So basically, it runs a function or a method, right? That is change what's in the DOM originally with the script that is being used. Okay. So they can hijack the user account, like what I give you as an example, right? Someone can hijack the user account while they're processing that transaction, redirect that user. And this can be like bank transfer, stock purchases, typically you see higher targets that are, either enterprises or high-end accounts, right? Because they want a lot more for return on investment when they're performing this kind of attack. And so it gives you the additional steps of breaking down, right? Sometimes the user would get a 404. And if they run PHP for the web server, you typically see PHP with like Apache, and that's like Linux OS in the back, right? So the payload is then being placed in the path and it is vulnerable. Okay. So let's go to the next question. It asks you to identify the type of cross-site scripting based on the given scenario. We talked about DOM-based cross-site scripting already. So it uses JavaScript, right, to control the sources and then hijack the account via the browser. So that's typically your DOM-based cross-site scripting. Now, if they include a malicious URL that requires the user to interact, and typically this is used for like capturing account login, right? So that they have to inject the code and get them to be able to submit something maybe and route them to the vulnerable website that they create. I talked to my class last night about fast flux because they are for studying analysis, right? Fast flux is used to acquire domain quickly and deregister domain quickly. This is a tool that's actually being integrated to generate water holes and malicious domain very fast. This is why it's harder for us to track these type of malicious website or control it in general globally. So what you see is that when you are getting redirected as a user through your browser, that means that the malicious code is executed and they're sending you to a similar server that might have something that you might not cause any kind of suspicion. So that way you can enter your password or do something that they would be able to acquire your information. And so you have to kind of do user redirection that way. So this is called a reflected cross-site scripting, where it looks at that as a trusted source on the user end. And a lot of the times people as a user they're not aware of that, right? Because technically they don't know what's happening on the back end. Now, if they're able to access the configuration of your servers and your databases, right? The attacker can also store the script on there. This happened a lot when we used to allow backdoor. This is no longer in practice that for development that you cannot have backdoor. That means that you cannot open the back and so that way developer can go in and change the content anymore. You rarely see that these days. But if they're able to get into some administration configuration account, what they can do is they can add a script and automate that, remotely controlling it to be able to run. And so when this script is run, then they would be able to obtain, right, information that the victim or the user actually submit, okay, based on what's on the database, like social security number, like credit card information, like healthcare information. So C, that will be your stored cross-site scripting. The keyword here is stored. That means it's stored script, right? And then D, the attacker submits malicious payload using form. Once the user or the admin is activated or the application is open, then they would submit that to the back end of the application, where the back end of the application is where, configuration, the code is actually ran for the execution. Then they would be able to get the payload to execute. So the data itself, right, is submitted into the form. So that will be a script that we'll really look at, because a lot of times when you're looking at a web application, it is a way for the user to retrieve data or to access data, right? I'm sorry, to input data or to output data. So if they submit something that is part of the payload, then it's going to then execute in the back. So this is called blind cross-site scripting. Now, this is just a summary. I encourage you to look at the specific, right? I give you additional example on how that looks. Like for this one, right? To redirect. So when you're looking at the URL, you typically would see some information. So when you assess something like this, right? If it's getting rerouted, then you would see that in the parameter of your URL. Especially when like people are searching for items and products online. And then they can also inject the script into it, like this. So if you have like those fields that when they can put in comments or, reviews, things like that, right? That is a post in HTTP. So what that can do is they can manipulate that, right? To be able to add in the requirements that they need there. Any question? Now, if you know secure browsing, Chrome and Microsoft browser, a lot of the browser now are really created to scramble the URL. So that way, like even if you inject the script, it might not come in entirely as an entire script. That really is a low level protection on the browser end. But you cannot rely on that 100% because as far as how you build your web application and website, you have to consider that potentially someone can actually inject script for these form of attacks. So you need to assess to see if it's accepting scripts before you deploy your web or web application server, right? Okay. So here I noted that for the blind cross-site scripting, it says that it is very hard to confirm. This is one of the more advanced ones, right? The tools that you can use to assess this is called cross-site scripting hunter. This was built to be able to really look at, right, whether the script is injected for blind cross-site scripting. So earlier I talked about traversal, directory traversal. So if you know web development, right, you make folders or directory to have content. So for example, I'm going to have an index.html that's going to be my landing page, but then every tab that I wanted to add for my web application, for example, like profile, where I can have the user click on like payments, things like that. It will be organized in subdirectory. And in that, you would have the code, all the resources like images, objects that you want to put in there, right? So when the attacker can have access to your directory, there's a technique that they use is called directory traversal. This is a way that they can go back to your web root, which is your main content, right? Where your index and your entire website is in that container or that folder. And they can try to execute some kind of command to be able to find things like admin accounts, right? Or some information that is only permitted for the inside people to be able to access. So directory traversal is like one of the most common form that you would typically see in this area. And then we talked about denial of service attack already. That's basically just generated massive amount of requests where it will be overwhelming to your server. Okay, so how can we control some of this? One, you need to really look at your software tools that you use, right? Even for the languages package, libraries that you incorporated in your web development. And then also, if there's updates for the services with the protocols, like the version of the protocols that you use. So making sure that you are updated and fix all the issues that are vulnerable with on the software side. You need to make sure that your policies are applied to access control. Like we talked about credential, right? Strong password. Multi-factor authentication is not that excellent in security, but it is another level that you can implement. Secure coding practice, we talked about that, not leaving backdoor development and design with security in mind. And then you need to use your security appliances to detect these things. You can use web application firewall, you can use IPS and put in the rules on how it looks at. So it blocks the script. So you need to tell it what is a script, right? And what form of scripts that is allowed and what form of script that is not allowed. Because in some sense, we have scripted for automation in the back end as well, right? For the purpose or the goal of the web application. So you can use your security appliance and have effective rules in order to do that. Don't keep the default configuration. So these are the things that you need to know, right? If you have web or web server or web application. And then turn off the protocols and the service and their ports. right? If they're not being used, like don't use port 80, right? I know I showed you how that can be easily accessed and turned on, right? Somebody can scan you and see that your port 80 is used and port 80 is not secure. So we don't want to use any protocol that's not secure and turn off the services in the protocol that you don't need. And then also implement malware live monitoring. So you can have an anti-malware server that is running for your entire network, including the DMZ area, and making sure that it's scanning everything that's coming through. So they can have it embedded into something or hidden into something. Okay, so let's look at the next area. And you can clip that from the notes or you can summarize this. When you turn it in, you don't have to be verbatim, right? I just want you to have the knowledge in this area. If somebody interviews you and asks you, how can you protect a web server? You need to kind of summarize these things, right? You can start with like, oh, running updates, making sure I have strong policy implemented for access, right? Applying least privilege and access, and then being able to change the configuration and not keep default configuration. So disable default accounts, right? Because a lot of the systems come with default account, like root. Okay. We don't run root unless it's absolutely necessary. So you create custom account for specific level, even if you have administration requirement for a certain type of account, right? So those things, these are the things that you need to know for web security. In the next section, it talks about CSP. When you use ZAP, you're going to see some of this, right? So content security policy, this is used to look at, to inspect, right, potentially attacks that would be for your web or your web application. Now, the attackers, they know that there's CSP that's integrated. So for most in all web development, so they can bypass it. So CSP restrict the resources such as scripts and images because images can be obfuscated. That means that I can have something in like a malware code that's embedded in the images, right? You might have learned obfuscation in another class, and we're gonna do a lab on that, right? So how can someone add something into a typical object like an image? Really easy. There are tools that you can just put in, or they can add a script into it. So CSP control, right, what can be allowed on there, right? So we want to be able to control the scripts and the images when it's loading the page, and it's restricting the page based on the frame. So this is like a low-level security that we can implement for web development. Now, to bypass that, they need to modify the code that you have in your your website, your web server, right? So they need to inject HTML element because that's what web servers use, right? So that way you can see the content on the browser as a user. And so when that's clicked, it would then store everything to an external server. So they have to set up an external server in order to do this. So it's going to execute and then pull everything and put it onto the external server. And then basically it's a way to overwrite, right, your main source directive for the CSP to inspect. So it causes confusion to the policy, so it cannot follow the rules. Policies is typically just rules that it used to see what is bad and what is good, right? So if it causes a confusion for the policy, then it's not able to inspect script or images that's being passed through. Okay. So this is a way to be able to bypass it. So before they do this form of attack, they would look at your content carefully. It's easy to grab HTML code and look at the content, right? They might register for an account. So look at the elements, the feature in your web application, like, oh, what can I click? Where does it take me? Right? What kind of requirements in authentication for this? So the recon for this is going to take a little bit of time, but it really builds out the knowledge in that. So as a pen tester, you need to do the same thing. You need to be able to inspect the elements of the web, the content, the features, the code, right? All the interaction that's in between from the front end to the back end, right? So a good attacker is one that does the homework. Same thing with the pen tester. A good pen tester is one that knows everything inside out about what they're about to target. And so that brings us to the next part. So what kind of information that you need when you do reconnaissance for web? First, fingerprint, right? We want to find the operating system version because the majority of your web servers are Linux servers, right? There's some that are Microsoft. You guys turned that on when you did remember how you have the Windows system, you enable IIS, that's Microsoft service for web. And then you also activated Apache or IGNX, which uses Apache, right? You already know how to turn on web services on both sides. So from an attacker standpoint, they can run something like Nmap with your public IP address and see how your system responds to the request. Nmap runs scripts and it queries your target, right? So it's going to tell you what kind of software, which web services that's used, Apache or IIS, and also the operating system, right? Like, is it Red Hat Linux, Debian Linux, Ubuntu, Windows, which version? And then going from there, they're gonna look at the vulnerabilities in those, like, oh, what can I do with these OSs? And then we talked about some install software. In web development, sometimes we need to add software to give it a next layer, right? Could be for graphically related. So if you're looking at a gaming software, that's not just, yes, you can code all the way through, but there's animation involved, right? There's graphics that you need to pull. There's things so software is going to allow the designer and developer to integrate a lot of the elements for the web. So look at the install software, the protocols, that's kind of coming back to the services, but protocol speaks to ports. And ports are like windows and doors to the system. So we wanted to, and they're going to see like what protocols and what ports are being used, right? And in a web server that requires authentication, it's going to link to authentication systems, right? It's going to have certificate. It's going to have if you have security components with encryption, then you are going to have some form of trust, right? So they're going to study a lot of that. We talked about protocol, open ports, and web server cannot exist without domain name, which brings you to DNS, right? DNS, they can also attack your DNS by redirection, by poisoning your DNS record, because the domain name system, its job is to do what? Have a file. That file is used for correlation between the public IP address and the registered domain name, right? Which I acquired from the web hosting company. And IPv4, IPv6, it also being used for other components like if you have an email servers that's attaching to your web servers and so on, right? So it has these records or file that is being used with its own component for web domain services and also, right, other servers like mail exchange. And then credentials, vulnerabilities, everybody has a database, whether you use relational or non-relational, right? So, and with that, you also have software that's here, right? If you use NoSQL, you have to have that software package. If you use SQL, you have to have that software package in order for your SQL to work. So your web server typically talks to the database because nobody stores thousands of users on the actual application. We take that and we port it into a database. And then your session ID, your cookies, and also they wanted to see if there's misconfiguration to your server. So basically looking at the flaws, right, of your systems. So if you are a pen tester, these are the things that you need to find, right? Like I said, the majority of the time is going to be spent on recon. The more information you have, the better it's going to be. And then the next step is to be able to move that into different stages of attack. We'll come back to the stages of attack in the later sessions. So once they have the information, then they would know the tools or find the tools that they need, okay? Or build it sometimes. So the steps after they have after gathering information, right, is then finding the tools for execution. So typically you see these form of attacks with your web server. Okay. So session hijack, because if they know your session ID, then that is a way that they can also hijack. Password, we talked about enumeration and brute forcing. Man in the middle, so typically you see this and this together. Man in the middle and hijack. And if denial of service, we have a whole chapter on that. So if it's distributed or denial of service, then, so that it will just cripple your server. And then website redirection, that could be cross-site scripting, or you can have DNS farming, or basically changing the DNS records, right? Or DNS poisoning. Any question? So in this area, if you want to really, perform, like if you are doing offensive security, which is basically you are, doing ethical hacking along with investigation, which is a little forensic with it, then what will be is that you need to know programming, right? JavaScript, HTML, Python, Java, right? Also Lua and other languages like Go. I recommend that. The university and the schools, a lot of the time they don't teach those things because those courses to a lot of the professors are like, oh, we'll just teach C, C++. Knowing the objective oriented languages are good, right? It's good for native applications and also some web application. Having that programming concept will probably give you a little bit of leverage in learning other programming languages, but I highly recommend learning web-based languages if you want to get into this area. And then database, very important. Everybody has a database. Okay. Let me see. Maybe I can move. Let's move 7 down. And these guys up. Okay, so in the next part, it talks about web mirroring. Website mirroring is a way that the attackers can take whatever you have as far as web development and then simulate it, right? Make it into where they can inspect it. So they would study like how you build your web site and web application, and then take your code, all the features and the components that you have, put it onto their local systems or even a remote servers, and be able to simulate that, right? And then go through the steps to really look at like how can this be successful. So it is a way that they can study the structure of your website and web application in details. So can we really stop a lot of these things? It's public facing, right? You can do some configuration to not allow the people to look at the HTML code, but as you know, right, you can look at the majority of the websites that are out there because But you need to really control it from the back end on what they're gonna do with this. So focus your energy on like how we can control the internal the back end structure a little better. Um, okay, so CSP, we already talked about that. You can find that on page 6 and 7, right? We talked about some of the type of attack and the phases that they go through. And the next thing we're going to talk about is your cross-site request forgery, your CSRF. So in order, this is lengthy, right? I know it's like one of the more wordy, but you can summarize this. So to perform CSRF, cross-site request forgery, what needs to be there, right? What kind of environment or conditions that the attacker must have? So one, the relevant action with application that the attacker has a reason to induce. That means that they need to have access at a higher level to modify accounts, right? Users, so that way there's processes and actions that's involved, right? Like changing passwords, like modifying the account from a regular user account into mid-level or higher level. So escalate the privilege there. Okay. So how can I do that though? Right? Phish, right? Phish the people who has higher level access, like your admin, your developers, right? I can phone phish, right? Or voice phishing. I can, send emails, and that happens a lot, right? So you see this type of attacks, there's plan and operation, and it usually performed with other form of attack. Cookie-based session handling. So everybody make you store cookies these days, right? Because cookies, we talked about session hijack and session ID before. Cookies allows you to, as an organization, to market your product, right? Your browser is listening to you, everybody. Based on the cookies, it really looks at, like, it stores information about how user access web content. Okay? So cookie-based session handling, it allows the user to conveniently come back to that session, right? Like, for example, I log in and I add a bunch of things to my shopping carts, and then I close my browser. I'll come back later and make the purchase, right? The cookies is going to store everything that I put on the shopping cart. So I'm going to come back in like a few hours later, go back to that website. It might just bring me back to where I was, because the cookies also have my credential information, right? And then it loads my shopping cart, all the items that I added a few hours ago. So in that sense, that web application actually used cookie-based session. And so all the requests has already been submitted to the server, and it already has response. So it basically reload the session that I had, right? And so in that sense, they can capitalize on it. They're going to use the session ID, the session cookies ID, and be able to identify how the user submit the request, right? Like adding things to my shopping carts or process transaction, enter my credit card information, that kind of stuff, right? And so that way that they can do a session hijack or forgery, right? Force that request as that user. Now, all requests to the system, because the system only accepts certain form of requests, right? There's a parameter with the request. So they would look at the action based on guessing, like if I submit this process, this is the request one, and this is how the server is going to respond. So an example that I put here is when the user changed their password, right? The function is not vulnerable if the attack needs to know the value of the existing password. So you ever go to a website, you don't need to know the last password, right? You just need to, if they use like multi-factor authentication, you just need to have like text or email, right? But in some websites, you have to know the last password in order to reset your password. So that means that this function is then not vulnerable because they need to know the value of your last password. Most people don't do this anymore because if I know my last password, why would I need to reset my password, right? It's not logical. So what they do is they implement multi-factor so that when you get an OPT or you get the text, right? You get the email and then you copy and paste that in. But guess what? When you copy and paste that code in, what happens? It generates that session for that, right? So it opens another layer. So like I said, just buying time. It's not very secure. Okay, so forgery is a way that they forge the user accounts, they force the session, they forge, you know, the information. So how can they perform this kind of attack? It's built into some frameworks, it's built into some exploitation packages, right? Or exploitation frameworks. But Burp Suite would allow you to perform POC. So it does a POC generator for CSRF. So that's one tool that typically is used for CSRF is Burp Suite. And I mentioned before that you can check out their tutorial on PortSwigger website. They do a good job in, showing off their tools. So I recommend this if you want to get into this area. Okay, so we touch on these. And then here it talks a little bit about POC for Burp Suite, and this is the professional version. If you get the free version, it might not have all the features that you need. You can get like the trial professional version, which gives you like certain number of days, right? And it walks you through the steps here. So how can we fix this problem, right? Because we already know that this is happening. We can generate what's called the CSRF token, which is a unique uh, object that is not predictable. It uses unpredictable value that will be generated from the server side. Remember that when you have these tools, make sure you check them out, right? If it has a seed, then it is predictable. So it has to seed based on system time or something that is non-predictable. Even though it says it's randomly generated, make sure you look at how it's randomly generated. So ask the question before you acquire the software to be implemented for web development. And then you need to assess that if it's already there. You probably have seen same-site cookies or have heard of it. This is used for your browser security, and your safe browser mechanism also have incorporated or same-site. So same-site restriction would prevent cross-site for most part. So Chrome enforces lax same-site restriction by default. I think they changed this now for your browser and then to be able to adopt behavior. So you see a lot of the browser development, the improvement in security for browsers because of these forms of attacks. You can also inject into the browser. That's why they did the scrambling for the injection purposes and then other things. So but your browser by default, you can select like how you want to use your browser. So that's really important from the user standpoint is how you browse, right? Some website they force you into, but by regulation now, right? They have to prompt you whether you want to allow or reject the cookies, right? But they can make it where it's harder for you to reject because they want to store the cookies to know what you're looking at. Okay. You can use refer-based validation, which is a way that you can use HTTP referral header. It's kind of like I want to send the packet from my house to my friend, right? But instead of like going through the post office, right, I'm going through another shipping company that passes to another shipping company. My package will get there, right? But it's like there's a middle systems that refer the header. We do this to control some form of attack, right? The referral, we talked about denial of service. We can use it to refer to a black hole, a system that absorbed the attack. So you have to set up a referral, and what it does is it looks at the header for the request. And in this form of attack, it generates the request. So it verifies the request for the where that's originated and where that's supposed to go to. Because the header, it's like the label on your package. It kind of tells the system like who's sending, who's requesting, who's responding. So it's going to check that. So we use the system to inspect, basically, right? In addition to your firewall or your security appliance. Okay, so we talked about tokens. So and using tokens and to make sure that there's unpredictable value. We talked about token is a unique valid request. This prevents the attacker from executing the attack. Now, as you know, even when you have secure websites, not all of them are developed with these things, right? By practice, we should have these. This is why we continue to have some problems like this, because not all web developers implement. And sometimes web developer, their reason would be, oh, in order for this to work, I have to open this up or I have to code it this way. But when you look at that, you would, if you come in as an analyst or, somebody that inspects this and you tell them the problem, right? Sometimes that they have to fix the problem, and that means that they would have to recode or redesign some part of the website or web application. And that sometimes is not always ideal because they don't want to potentially it can interrupt their operation. Like if I'm an e-commerce website, I don't want to tear down my website to fix some of the problems right away, right? It has to be a process for me to do that. And in that you have a gap because that time that you lose, potentially someone can perform the attack. And then we talked about same-site cookies. So same-site cookies can be used to determine the website cookies, right, that are included for the request originating from the website. Now, web application is additional layer to your website, right? Most web server now is a web application server because when you go to the website, it's not just a static page, right? That you see. Rarely small business, maybe they have something like that. You would have some kind of interaction so that way there's an application and what processes that's involved. So for example, right, if you're using your Google Drive, that's a web application, right? Because you can upload, you can download, you can, share. There's many features that you implement into that application. Now, if you go to a website that has companies' contact information and maybe another page about their staff, that's just a website. So that web server just have a couple of the HTML file that would, so static websites are that doesn't have interaction. Can just code it with HTML. And then if you have the element of interaction, you have to have JavaScript or other languages to be incorporated. So in the web application attack, one, they're going to look at the application URL. The reason why it's not just one URL, you already know this, right? When you look at your URL bar, if you click different feature, so for example, I log in to pay my water bill. And when I click that I wanted to make a one-time payment, it redirects me to another system, right? Another site to take my payments because, then now they're protecting that area. So they are gonna look at like different URLs that's being used with the feature. But even if it's hosted on the same server, every single feature has extension to the URL that's included. Like, so for example, profile for the user account has an extension, so that way the user can modify their information. I might have a feature to look at my balance, right? Or my payments history, etc., or my past purchases. So those things is important because the way that they look at the URL is that potentially maybe there's a way to inject into the URL. Maybe they can, do something with the URL. So they're gonna recon and find the URL information. They're gonna look at your server's fingerprint, right? Open port services, we talked about that before. Your application frameworks and associated with subdomain. A lot of the times web application use some form of framework in the coding or development part of it to streamline some of the components in the development. And within these frameworks, while it is designed for efficiency and effectiveness in development, a lot of them also have issues. So we want to be able to see what kind of frameworks they use. A lot of the tools that you see in Recon actually shows this. It shows these things, right? So they can run a tool and be able to gather the information in one set. And if your server is protected, it doesn't respond to these requests in scripts, then it is additional time that they need to put in. Like I said, it's a race between time and resources, right? So if they have more time to look into your stuff, eventually they'll find it. So you want to make it harder for them to be able to find your subdomains. Like I might have associated subdomains in my development enterprise have a lot of this. Okay. Okay. Moving on. Any question? Okay, let's take back to the notes real quick. So hacking web application is here on page 9 of your 13. We talked about recon just now. Now we're going to get into the next stage, right? After recon is to discover, right? And map. So it's important to really look at the target application because your web server might not just be one server, it will be many for the application itself. And these are going to be entry point from a public internet area. Looking at your fields and your forms, your URLs, if there's hidden parameters for the query, that they can submit with the input, and then using crawlers to be able to find information that you can map and discover. So 15, it asks you, or 14, I'm sorry. In mapping discover phase of your web application attack, the components for the application are identified includes entry points, like how they can interact with your web application. Web application has to have interaction, right? Like username and password, that's an entry point. The reviews, right? The input, right? Like if you have a form for people to file a complaint, right? Reviews are a form of complaint, in my opinion. So forms, URLs, hidden parameters, using crawlers, we talked about that. And then they can manually map the application functionality. Like I said, right? Like once I click payments, it's going to take me here. And these are the things that I can do. When I click submit, it's going to take me here. It's going to map all of that. There's a flow in the development side. So they need to know that flow to look at your vulnerabilities. So now the next time that you access a web app, pay attention to these things, right? Like from a perspective of a security person, you need to kind of see like, oh, this is what it's doing. This is what's happening. I have a token here. And when I'm submitting this, it's storing this and it's storing my session, etc. So you apply the concept that you learned. So before we get here, anybody have any questions regarding stage 2? All right. The next, we're going to start looking into vulnerability scanning, manual testing, exploitation, privilege escalation, and post-exploitation. So these are the stages or the steps that you would see an attacker would go through to perform web application attacks, right? So in 15, it asks you to describe how insecure direct object reference or IDOR allow attackers to access restricted data. They use this or they manipulate, right, the IDOR, the references that are exposed to the web application, such as using the URL, right? That's why they gather URL or your database keys. And we're gonna work on database next week where we looked at like queries and how relational database, a vulnerable database look like, right? And how they can inject. So if you think about the URL, right? We saw some example for cross-site scripting in that they can inject the script with the URL, and that's part of the feature. So every layer of your web application, every feature that you have on there, you have to think about these things when you build it, right? I have many students, some of them finished computer science, like UCI, CR. And I tell them, oh, make your portfolio, make sure you make your portfolio. And so that way you can showcase your skills. And many of them, they would send me like, oh, can you look at my portfolio and give me some feedback? A lot of them, right, on their GitHub, typically they do a web application to show that they can build, a full-blown application on the web. Or, sometime it could be like a native application. But in that, right, like I always ask them, I was like, well, the functionality of your application is great, but you really need to think about these things, right? Because I know the classes sometimes they cover the security development, but from a security standpoint side, we inspect every single area. Okay, so earlier I mentioned that there's libraries, right? In programming, we use libraries for convenience and efficiency. Because why do you need to build the wagon when someone already created that for you? You just get on top of it and you're going to ride it. You're going to add more horses. You're going to make it faster. So in that, you do have some issues, right? Libraries sometimes are built a long time ago. And if you use something that is very historical, that tends to be the problem. So in 16, it asks about how the attacker can perform remote code execution, is that they are going to look at the libraries that you're using, right? So for example, if I'm going to build a web application like for mobile game, right? I'm not going to go and code everything from scratch. I'm going to pull stuff that is available to me, that like even animation, like color, pixel, like things that can put together a game. So I'm going to use libraries. And so with that, I have to think about like how these libraries are vulnerable, right? And so they're going to inspect your libraries. They're going to see if the libraries are vulnerable, and so they can capitalize on that, or they can find way to inject malicious code through your forms, right? We talked about the forms. So another way to control that is input validation. And I talk to developers about making sure you have input validation. If you learn JavaScript, right, or any languages, you can control that. You can also set a pattern. You can make it where you only accept a certain input. And this is how what you see is that sometimes when you're trying to type a certain character into a field, it doesn't let you, right? Doesn't matter which encoding system you're using, you have to think about like how I can control what is being entered into my system. And once it does that, I need to inspect what's entered into my system to have some kind of measure from the public side entering into your network and your network systems, right? So we can control injection with input validation. Not just like, I think in programming, typically I tell my students like, oh, make sure you do input validation because we don't want garbage, right? Like the cleaner you have data, the better it's going to be. Yeah, from the back end side, we want clean data so we don't have to clean it up. But you already know all data that's going to come in is not going to be clean, right? Even if, so the only way that's clean is to make sure system to do that, like automate the process because humans gonna have error. But anyways, like you want things to clean up, but at the same time, you want to control the security side to make sure that there's no injection that's involved. 17. Explain how security cryptography storage or encryption for your storage can negatively impact application. When I teach upper level classes, like my students, they love to tell me, oh, I will encrypt this and I will encrypt this. But I mentioned this before, right? If you learn about encryption, it really is about algorithm, key size, and length, right? How strong is the encryption really speaks to what kind of algorithm it uses, right? And then the size of the keys and the size of your encryption algorithm. So typically what you see is the stronger the encryption, the more resources that you have to put into it. Processing RAM, right? And sometimes network connectivity if you're streaming the encryption. So HTTPS, while it's using TLS for encryption, you still have to stream bit by bit, right? Now, when you store the data into, let's say, a database or a remote location, let's take database, for example. I have a user register an account and enter the username and password. I'm going to encrypt not the entire database, but a certain field, right? Why don't I encrypt the whole entire database? Because it slows down whenever the user trying to log in. You understand? Because it has to decrypt to match the password. So imagine if it takes you 3 minutes to log into an account these days. That's super long, right? So we have to make sure that it's instantaneous because we'll lose services that way. So if I encrypt the entire database, it's going to take a while to find the rows and the columns and then make sure that it decrypts. So storing that, we would then encrypt a certain area, like Social Security column, right, which is called field. And then we would encrypt other things. But the general information, like their nicknames, we're not going to encrypt that, right? So think about that. So if you're mishandling the keys, then encryption is no good. It's like locking your door and leave your key out in the open, so it's not effective, right? Or if you're using weak keys, like that's why I said key length is super important when you look for encryption. It allows the user to access that. And like I said, the decision in encryption is really relying on the priority of your sensitivity in the data, like the level of sensitivity of your data, right? Nickname, not important. We don't encrypt that, right? Password, yes, let's encrypt that. Social security number, yes, let's encrypt that. Driver license, let's encrypt that. So your PII gets encrypted, but other things, right, don't get encrypted. Okay, so let's think about, let's say that we are going to encrypt some stuff on our database or our storage of the data that's entered into our application. We are going to make sure that our keys are rotated regularly, right? So the key management practices is important. Where you store your keys and how you access your keys are also important, right? And we want to make sure that there's separation of duties, especially, that admin and root account can retrieve keys, right? But we don't want to rely on just those accounts, right? and then control how the keys are accessed and how it's used to encrypt and decrypt data. Can you automate this? Yes, you can definitely do that, right? Depending on the tools that you use, the encryption tools, and so on. So I'm going to give you a case example, right? I use surveillance camera for my property. On the web app, I pay a little bit more for them to store every single video with the encryption and the transmission on that with encryption. You know that like IP cams are like the most vulnerable because if they can access your like your ring, you already know people can access ring, right? Through Shodan or stuff like that, right? They can see what's happening at your property. So with that, like whenever I'm trying to access like my recording, it takes a lot longer because the app needs to pull it down, it needs to decrypt. And then with that, you pay additional fees because they need to manage that with the software, right? So you see a lot of these elements that's being used for like daily life and IoT devices and such. But is it worth it? Definitely, because when I before, I used to have a system that doesn't have all the security feature. And then one day I started to feel like something was weird with it. And then I logged in and I checked. And it uses OpenDNS. And I found that they were trying to inject script into it to access something. So you do see like, issues with a lot of these appliances that are connected to the internet and it's web front, right? Okay. All right. For 19, it asks you how can misconfiguration of cross-origin resource sharing or CORS lead to data through services that can be used without authorization? If you misconfigure your CROS, this will allow the attacker to access, right, unpermitted or restricted resources from a different origin. So let's go to that real quick. Okay, the main difference between us and the attacker, right? Even if you're going to become an analyst and you do some of this part, okay? Step 8 here is you document and you submit your report. This is where you make the money, okay? So if you work as a consultant, a contractor, this is what you do. When you submit your report, that's when they pay you, okay? But as a pen tester, so writing skills is important, communication skills is important. Yeah, it's important that you know. And now you can use OWASP to look at like, different areas of attack. So there's reference and guidelines for you to use. So, and don't do anything until you have authorization that is written, right, and review, okay? In some cases, you might have to refer that to a legal reviewer to make sure that if you do something, you don't get sued for it. So, okay, here it talks about SQL injection. We'll do that next week, right? With SQL query for relational databases, cross-site scripting, we touch on these. Forgery. So the same form of attack that you see in web as in web application, right? And then your remote code execution, your RCE. And then your security measures. So we talked about making sure your credential or your access is managed in a secure way using encryption, right? Controlling URL access. And then here is your cross-origin resource sharing. So this is on page 13, which is the last page of your notes. So COR, right? It is a feature that allows your web server to have domain information and its resources. So you need to make sure that you configure it because that's your entire web network, right? And so that Now, if the attacker is able to access that, they can access your data. And so you need to make sure that you configure the COR headers. You need to make sure that the libraries, right, that can be implemented, and making sure that your configuration is parallel with the interface. Okay, so for 19, we can say misconfigured COR will allow them to access restricted resources from a different origin. And then for 20, how can you reduce the risk of vulnerable components of your web application? We would start with monitoring or tracking your component versions. So in development, version control is very important, right? So talk to your web developer, making sure that we go back and look at like how they improve in areas. So if you come across, right, like a web application that is not secure right now and it's brand new, right? So in the next implementation for security, that needs to be then in the next version. So as you track through the version, you wanted to see the changes. So you do change and configuration management with this. You see the changes in the actual code, the changes in the configuration of your web server and services. And then looking at existing vulnerabilities, right? It's really this that really is your responsibility. So we want to manage the vulnerability. So we would use scanners to be able to see if our web server is showing some vulnerabilities. And from there, you take those vulnerabilities and fix them. And that's your job, really, right? So if you, let's say you work as an external contractor that do this, which a lot of people do, right? Like I think if you visit some website for job and you look, they hire offensive security people, ethical hacker, pen tester to look at these things, and then they're gonna create a report, and that report gets sent back to the internal team or the developer if they outsource that, right? Someone oversees programming their website or web application, then that goes to the web developer, and then they would need to fix the problem. So you tell them what to fix, right? You don't need to fix it because you're not the web developer. You need to tell the web developer what areas to look at to fix. And then they'll come back with the next version, and then you check that again. Okay. And that's how you make your money. Any question? Okay, so let's stop here.